Hello guys, welcome to my stream. So yesterday we have solved two problems of sliding window, and I forgot to share my screen. So I just made that video private. So I think hopefully today my screen will be visible. So let's start, guys. As you can see, it's cold out there. Okay. So first question is permutation in string. Okay. Let me sign, guys. Okay. Given two strings s1 and s2, return true if s2 contains a permutation of s1 or false. Given two string s1 and s2, return true if s2 contains a permutation of s1. Okay. If s2 contains a permutation of s1. In other words, return true if one of the s1's permutation is the substring of s2. Okay. So basically, we need to check if S1 is a permutation of S1 is a substring of S2 or not. Okay, so permutation basically means arranging S1's characters in any position. For example, what's this? Okay, this is my description. Today's chat's description I have copied from ChatGPT. So basically, AB and BA are the permutations of AB. Similarly, for ABC, the permutations will be ABC, ACB, BCA, BAC, CAB, CBA. Six permutations. Okay. So I guess number of permutations can be defined as number of permutations permutations of a string of size n equals to 2 raised to the power n minus 1. This was example 1. This is example 2, guys. Okay. So the number of permutation of a string of size n are 2 raised to the power n minus 1. For example, here size of string is 3. So if we put 3 here, so 3 minus 1, 2, 2 raised to the power 2, 4. No, guys, I think this is wrong formula. Mm, and factorial permutations. Basically, permutations will be n factorial. For here, size is 3. So basically, 3 into 2 into 1 permutations will have, which is equal to 6. So basically we need a substring in S2, in which substring same as size of this substring, having frequency of numbers same as this string. Yes, that will work. Means the frequency map of S1 should be equal to the frequency map of some substring in S2. Uh, so brute force approach will be checking every substring of S2 of size S1 dot length. This will have a time complexity of sorry guys, my cold is not getting better. So basically, we need to find. Okay, I have thought of a very intuitive solution. So basically, first we will create a map. In that map, we will store frequency of all the element of S1 string. Okay. Then in S2 string, we will run a window of size M, and we will subtract a frequency of that elements from the map. Okay. So if at any point of time, if our map gets empty, so basically we have found a substring. So let me show you. First I'll create a hash map. Okay, hash map of a character and integer map equals to new hash map. So basically this is the syntax to define hash map in Java. Key value pair, basically this is the key and this is the value. So we'll have a character type key and integer, we'll be storing frequency as the integer. So for int I equals to 0 I less than m I plus plus, we will put s1 dot character at ith position. If this character is not present, okay. So we are doing nothing, we are just putting s1 character and increasing its frequency. So if it's already not present in map, so we will be by default taking 0 at the value and then adding 1 to it. So basically adding one frequency. Okay, map dot get or default. Okay, now we will iterate. This means we haven't found any. Guys, we also do have a contest today at 8. So actually we can't solve a contest on a live stream. So that is against LeetCode's policy. So I think I'll be attempting today's contest also. until my I is smaller than the size of this string, which is 4 s2, I need to subtract the frequency instead of increasing it. Okay, after this point, I will have put this much element. Okay, so a base condition would be something like this. If n is smaller than m, I can return false. So it will be not possible to have a permutation. Okay, till here I have added all the elements. Okay, I have added all the elements, and I will check if my map dot size is 0. Then I return true. Otherwise, otherwise, if I is equals to n, I need to break. Otherwise, I need to dot char at I minus m map dot get or default. Suppose I have reached 0 1th index. For 0 index, I will put put s2 in the map. Now I is 1. For this also I will put into the map. Now my I will increase, so I will check if my size of the map is 0, then I return true. Otherwise, I will subtract this element. Basically, 2 minus 2 is equal to 0th element E from the my window. New window will be this. I think this will work. Okay, so case 1 I am returning false. Okay, so one thing I need to do here is if map.get I minus m is equals to 0, in that case I need to remove. Similarly for this case. Let me try run my code. So basically this is our S1 string. So basically we will put into the map A and B. Our map will have A as frequency 1 and B as frequency 1. Okay. Let's try. Printing this map. A as frequency 1, B as frequency 1. Okay. So we are good till line number 22. Okay. So after that, we have started our I from 0 till n. So initially we'll not go into this loop. We'll only go when our I will be greater than here m is equals to 2. Basically our I will be greater than m minus 1, which is 1. I will be greater than 1. So basically we'll be going into this if condition only if our I is greater than 1, or if it's equal to uh, it's equal to n. Okay, so basically n here is 1 2 3 4 5 5 4 3 8 8. So we will subtract these two values from the map. Whenever I reaches this position, our map will look like this. A is equals to 1, E will have minus 1 frequency, I will have minus 1 frequency. Okay, then our I will go here at D, so our I becomes 2, so I will become greater than this value. Okay, so we'll check our map size. We'll skip these two conditions, and now we will put into our map. We'll add a frequency of this element I minus m. Basically I is 2, m is 2, so zeroth position. So after this we'll remove this from the map. Okay, then our I we come out of the loop and subtract d from here. This frequency we'll put d into. Okay, so now our I reaches b, so we are part of this window, so we go into this loop and add to i's frequency, and i's frequency will become 0 and we'll remove I. Okay, similarly we go to a position. We'll remove this and we'll add to. Okay, we'll subtract b's position, and we'll remove b from the map. Okay, so now we have d in map. Now we'll go on a. Okay, we have reached on a. We have reached a, so we will subtract 1 to a's frequency. Sorry, we remove add to d's frequency. Okay, and after here we will subtract from a's frequency. Now we reach this point at O. Our map side should be 0. Then why we are not returning 0 here? Let's try printing out our map. Okay, I'm not understanding why at I is equal to 2, we are getting frequency of E as 1. It should be 0. It's minus 1 here. Why it is becoming 1? It should be 0 if I am adding 1 to it. Okay, I understood. I have made a syntax error here. Okay, so we have got a vast solution. Let's look at my previous submissions. Basically, I am using rolling hash function and checking for anagrams. Why I have written so much code to find anagrams? Let's just optimize this code. Hmm, Actually, my previous solution's time complexity was a big of n, and for this solution, the complexity can be vast. Can the complexity be vast? Mm, yes, it can be vast. Because this hash doesn't give me a surety. Okay, so check anagrams. I have to check whether SNT are anagrams or not. Okay, so I have taken a frequency array. Okay, so length of my SN would be same. So let's just take this length. I have defined an array. Why I am using a count variable here? Okay. Uh, Okay, I think this should work. If my hashes are equal, I will check the values are anagrams or not. Okay, so this solution's time complexity is n square in worst case. Because having equal hashes doesn't reduce anything in worst case calculation. So yeah, let's see solution forum if they have any better solution. Java solution sliding window. Okay, what they are using? Nothing. They are just using arrays instead of map. Okay, so we have found a good approach. Uh, let's just move to the next question. Minimum window substring. Let's find this problem on LeetCode. Okay, so we have found this problem on LeetCode. Wait a second, guys. two string s and t of length m and n respectively. Okay. Return the minimum window substring of s such that every character in T, including duplicates, is included in the window. If there is no substring, return the empty string. The test cases will say that the answer is unique. Minimum window substring is okay. So basically, we need to find a substring in S which contains all the character of uh, this substring. Okay, this is pretty easy. So we will expand a window till we have found all the elements of T, and then this is our right. This is our right pointer. This is our left pointer. Okay. So right pointer, left pointer. So initially they will be here. So first, mm, we'll increasing our right pointer and find elements. Uh, we'll stop our right pointer when we find all the elements of T in S. So we have now this substring, and then now from we'll shift our right pointer till it will not affect our input. So shrinking from right, we can minimize our substring window. So this is similar to the previous question we have done. Let me show you the example. Is my screen visible? Okay, I think it's visible. Okay, so we have suppose our pointers are here. Okay, we have found uh, A. We move to next. We move to next. We move to next pointer. Okay, we have found B. Move to next. Okay, we have found C. Okay, so basically this substring contains all the characters of T string A, B, and C. So what the size of this string? 1, 2, 3, 6. Okay, so we'll now uh, move our left pointer to the right. Right till we haven't found a. Okay, so after we will reach here, uh, we have subtracted a, so we no more have a our window. So basically we need again we'll move our right pointer. Okay, we haven't found a, we'll move our right pointer till here. So we have found a here. So okay, this is also a window which contains all the elements. This is also a window which contain all the elements. This is also a window which contain all the elements. After we move our left pointer here, okay, it doesn't contain all the elements. Okay, so we need to move to right. Okay, we have moved into right. Okay, we haven't found. Okay, Basically, this is more of a two pointer problem than a sliding window. So these are our pointers. Let's call this left pointer and right pointer. We'll move our right pointer while it's first. Let's calculate the frequency map for string t. Okay, so we have calculated frequency map for our this part, which is A is frequency is 1, B is 1, C is also 1. We will also make a frequency array for a string. Okay, so while my my left pointer is smaller than right pointer. Okay. Mm, at the end, I need to return minimum size of the window, which would be initially let defined at the maximum size. Right pointer minus left pointer and min size itself. Okay. So at the end, if our we will return if our min size equals this value, this means we haven't find any window. We will return -1. else we have found the answer, we will return min size itself. Now we need to return this function means found, need to implement this function. Okay, 0 right 0 minimum size is this frequency of t. We have stored frequency of t string. Okay, okay, we also need to move our right pointer. Now let's implement this function. So basically this function will find if my t is part of my s string or not, having this as the left pointer and this as the right pointer. So this will have boolean type. Okay, so frequency of t, frequency of s. Our frequency array has a size 26. Okay, so if frequency s ith element has size frequency smaller than is ith element, then I can say t is not contained in s, so I will return false. I will return true at the end. Okay, for each is not applicable to expression type. Okay, I think we cannot use advanced for loop for strings, so let's just. Okay, instead of minimum size, we need to return the string itself. So let's define our answer string as empty, and here if my minimum size is greater than right minus left plus 1, so I have found a smaller string. This would be the size of my new substring, and my new substring will be within left pointer and my right pointer. So basically a substring function returns a substring between left and right pointer. For example, for this string, if left is 1 and right is 3, so it will not index 3th index. So basically s dot substring for this string will return this is my one index, this is my second index. Okay, so this will not include this part 3. It will basically provide me a substring of 1 and 2. So basically for here the substring will be d and o. Okay, Minimum size is greater than right minus left. Okay, so we are dealing with capitals. So we need to separate capital A's from here. Okay, index 32 out of bound for 26. How we are getting 32 here? Do we have other characters also? Uppercase and lowercase English letters. Okay, S and T consist of uppercase and lowercase English letters. So one thing we can do instead of doing this, we can create simply a array of 256 and just backspace this. So we don't have to make any base indexing. Okay, for this our function is giving AD as the output. For enter is equals to 0, t dot character at I. Okay, stored for ABC. Increased frequency. Okay, if T is contained in S. Okay, so in order to T contain in the S, okay, T's every element should have frequency. If T's any element has frequency greater than, so basically it is not contained. If it is not contained, we'll shift our right pointer. Okay, so uh, let's just first debug this problem, this part itself. So basically, our T has A in it, so we will increase A's frequency. Okay, so after that, we'll iterate our S. So we'll increase our okay A's frequency. We have increased A's frequency. Okay. Mm, okay, so we also need to have equal condition here. So basically, for this part, t is contained here, we will decrement uh, is frequency, left part's frequency. You can also do it here. Okay, we will check if one is our. Okay, we will give this left plus right plus one. Okay, okay. For this part, we will store a as a frequency 2. We will move our right pointer in this string. Okay, so we will add is so basically this is my t array. This is my this array. I add one frequency here. I will check if t is contained in s or not. So I have this array in this. Okay, okay. So 256. I think this will work now. Okay, so basically I forgot to add 256. Basically, our new size array is now 256. Basically, we have 256 characters in UTF-8 encoding. So this array will cover every character in this string. But in particular in this question, we can only have lower and uppercase alphabets. So let's try submitting it. Okay, we have found the submission. Let's analyze its time complexity. See, so basically, the time complexity will be big of s dot length. So basically, this is a big of an approach. So this is the most optimized approach for this question. Let's see my previous submissions for this particular problem. Okay, February 4th, 2024. Okay, so I have used a hash map previously. Okay, so these two submissions are similar. So I think today's submission is uh, clean compared to my previous submissions. Okay, let's see this section. Java solution using. Okay, so I think our solution is pretty much good compared to other solutions also. Okay, so we do also have a easy problem here. Best time to buy. Let's search this problem on LeetCode itself. Okay, so the problem is saying you are given an array prices where price I is the price of a given stock on ith day. Okay, so basically these are the prices on the ith day. This is the price on 0th day. This is the price on first day. Okay, you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay, return the maximum profit you can achieve from this transaction. Okay, so basically question is saying this is the price of stock on different days. So basically we need to buy a stock on one day and need to sell it on another day, and we need to return the profit. For example, for let's see, in this example our output is 5. So basically uh, if we buy our stock at price 1 rupees. Okay, so we have bought our stock at price 1 rupee, and in future if we sell it on at the price of 6. Okay, so we have bought at price 1 and selling it on the price 6. So basically 6 minus 1 is 5. So 5 is our answer. Basically we can earn maximum 5 rupees profit. For this example, basically our output is 0. So basically we are not earning any profit from here, because uh, our prices are decreasing on consecutive days. Suppose if we buy at 7 rupees, so in future we can see we don't have any day where our price is greater than 7. Similarly, for if we buy at 6, we cannot sell it in future greater than 6. So basically that is why we are getting output 0, that we cannot achieve profit. So basically we will try every pair, means we will try to buy at every day and try to sell it in future at every day. So we'll calculate maximum out of them. So let's just first implement. So this is the length of my prices array. Okay, so I will start from 0th day and will go till last day. Okay, so this is my current price will be price on ith day. So basically this is my current price. Suppose I have bought at this price. Okay, now in future, uh, suppose I have bought on price 7, I want to sell it in future at any, I will try selling it at 1, at 5, at 3, at 6, and at 4. So basically I will start from j is equals to I plus 1. So basically initially I is 0, so my j will start from 0 plus 1 1. J will start from 1, will go till end. Okay, so my future price will be price at j. At this price we need to sell. So our profit will be future price minus current price. Okay, so suppose if we bought at 7 and we are selling it the just next day at 1. So basically this will be 7 minus 1 equal to minus 6. So our profit will be negative. So as the question says, whenever we cannot achieve any profit, we need to return zero. So in the case of negative numbers, we will be returning zero. Okay. So if our profit is, let's also take a answer variable answer. So our answer will be zero. Okay. So if my profit is greater than my answer, okay, so answer is zero. If my profit is greater than zero, then I will be storing my profit into the answer variable. Okay. And at the end, I will be returning my answer. So let's call this current profit, current profit slash less loss. Let's try running this. Okay, let's try submitting this approach. Okay, so basically we are getting time limit exceeded because our outer loop is taking big of n time, and our inner loop is also uh, taking big of n time. So in total our time complexity is big of n square. So that is why we are getting time limit exceeded. Okay, so we have to figure out a approach where we can solve it in big of n approach. Suppose we maintain a minimum bought value. For example, here, if we start from here, we have minimum value on which we can buy this stock is 7. Then we move to next index. Now this value becomes 1. So we can buy stock on value 1. Okay. So for every step, we can maintain a minimum value on which we can buy our stock, and we'll try to sell it then. Okay, so for example here we bought at 7. Okay, but here we can bought it, we can buy it on 1. Then we can just move next. Okay, then we can just move forward. Okay, so suppose the minimum buying is prices of 0. Okay, if we want to sell our stock, our answer will be met of minimum of our answer, sorry, maximum of our answer, and it will be, suppose we are selling it today, this is our minimum buying value. Okay, so this will be our profit, and then we'll be updating our minimum buying value at the minimum of minimum buying value and our current price. I think this will work. So basically, what we are doing here is we are choosing the minimum value on which we can buy, and simultaneously we are trying to sell it. For example, if we want to sell in fourth day, in fourth price, we will check our rest of the array and check minimum value here. So here minimum value is 1. So basically we can generate 3 profit here. Suppose we want to buy it at 6, we need to check rest of the array what is the minimum value. So minimum value here is 1, so profit is 5. If we want to sell it 3, we need to check minimum value here. So here minimum value is again 1, so profit is 3 minus 1, 2. Suppose if we want to sell at 5, our minimum value will be here is 1, profit will be 4. Similarly, for this example, if we want to sell it at 1, what's the minimum value in remaining array? So minimum value is 3. So 1 minus 3 is minus 2. So we will not book any profit. So we'll simply have 0 as the answer. Okay. Let's try submitting it. Okay. So in order to understand this approach, in profit is equal to current price is this minus minimum buying value. So this is our current profit. Okay. So if my current profit is greater than my answer, then my answer will be profit. Okay. Mm, let's look at some submissions, means solutions. I think this is more easy to understand. So if you want to check this solution, means read this solution, you can just search my profile. This is linked to my profile, and you can find this solution in my recent accepted solutions. So if you click here on my profile, you can find this solution here. And also I have posted some solutions. Okay. Okay, so let's do some more easy problems. I think we can do some binary search problems. Okay. So basically, we given an integer nums which is sorted in ascending orders. So this is the nums array. It is sorted in ascending order, means it is sorted in increasing order. and an integer target. Okay, so we are given an integer target. Write a function to search target in nums. If target exists, then return index, otherwise return -1. Okay, so basically we need to find this value, target value in this array, and we need to return its index. For example, here we need to find 9 in this array and we need to return its index. So 0, 1, 2, 3, 4. So 4 is the answer. Similarly, we need to find 2 in this array. So 2 is not present in this array. So in that case, we are returning -1. Okay. Also, we need to write an algorithm which runs in log and complexity. So first thing, in order to apply binary search, whenever we want to apply binary search, the array must be sorted either in ascending order or descending order. Otherwise, we cannot apply binary search. So here in the question, the array is sorted in ascending order. So first, let's take an example: 1, 2, 3, 4, 5, 4, 5, 6, and 7. Suppose in our target is 2 here. So we need to find index of 2 in this array. So what we will do in binary search is we will take a left value left value as the leftmost index, which is 0, and a rightmost value, left index and right index. So here right index is 0, 1, 2, 3, 4, 5, 6, 6. Okay, so 6. So what we do in binary search is we find middle of these values. So what is the middle of 0 and 6? It is 3. 6 plus 0 by 2, it is 3. So we will look at third index. Okay, so we will check whether the value at third index is equal to our target or not. So basically at third index we have 4, which is not equal to our target. Okay, so now we have two options: whether we our answer is present in this array or our answer is present on the right side. So how we can decide this? So as we know that our 4 is greater than 2 and our array is ascending, so it must be present on the left side, because on the right side of the 4 the values that will be present are greater than 4. So we need to move to the left part. So our answer will be present in this part. Okay, so we will move our right index to this index, left index. So basically 0, 1, 2. Now our right index becomes 2. Again, what we will do, we will add these values 0 and 2 by 2. Okay, so 0 plus 2 by 2 is 1. Okay, so now we will check at this index, middle of this, and this is 2. So is our value matching? Yes, it's matching. So basically we have found the answer. So let me implement this, then you will understand the approach. So this is the template, which which is basically universal template for the binary search. You can apply it into any question which is related to binary search. So we have a left index which is present as 0. Let's first define size of our nums array. We have a left index 0 and right index as n minus 1. Okay, so this is our left index and this is our right index. So while our left index is smaller than and equal to right index, So we will find mid index. So our mid index will be our right index plus left index by 2. So this is our middle value. So we will check if the value present at our middle index is greater than our target. So we can have three conditions here. So first condition will be if our value present at middle index is equal to our target. So basically we have found our target, so we can simply return mid index. So yeah, we have found our target at our mid index, so we can return our middle index. The second condition we can have is the value present at our middle index is greater than our target. So let's retake that example 6, and we need to find 2 here. So here our middle index will be this index. So if the value present at middle index is greater than our target, if 4 is greater than target, then what we need to do, we need to move on the left side. So basically we will move our right index to mid minus this position. So now we have shortened over this array to this array. Now we only need to search in this part of the array. Okay, so we have moved our right index. Otherwise, what we will be having is our middle value will be smaller than our target. That is, suppose if our target is 6, so in that case our middle value is smaller than 6. So in that case, uh, if we need to find 6, where we need to move to the right position. So to move to the right position, we need to consider this array. Means we need to take our left pointer from this position to this position. So basically we will move our left index to mid plus 1 position. Basically this is mid and this is mid plus 1 position. So we will be left with this array. We'll repeat this until our left index and right index coincide. So if we don't reach this situation, means if we don't find this index, means the value is not found in the array, at the last we will return -1. This means we haven't found uh, target. Okay, so basically this is the template which will be using everywhere whenever there is a binary search implementation. So let's try running it. Okay, so mid index, we need to mid index here. Okay, okay, so let's try submitting it. Similarly, if you want to see this code, you can just go on to the my profile, and here it is binary search. Let me just zoom out. So this is the solution. Okay, so I think this was the binary search approach. So I think you should try some questions yourself, like cocoa eating bananas is very famous problem, binary search problem. Okay, then I think we have solved many problems today. So we'll tomorrow we'll solve this problem sliding window maximum, and we'll start with the stack part.